Hello and welcome to this chapter. In this chapter, we will learn how to build the UI. The absolute positioning principle is the first section of this chapter. In this section, we will learn the absolute positioning principle, add widget in the absolute positioning environment, and common alignment, control of hierarchy, and use of banner widget. First of all, let's learn the absolute positioning principle. The absolute positioning principle is one of the two most important positioning principles in HeCode. Great housework must be paid enough attention to when learning. First, let's take a look at the definition of the absolute positioning principle. First, the relative position between the origin and the negative object is defined by the fixed xy coordinates. We intercept this paragraph and define the relative position between the origin and the negative object by the fixed xy coordinates. We can see that when we select a widget in the absolute positioning environment, there are two coordinates of xy in its property bar. At present, it defaults to 45 and 95, which is a coordinate we just drew randomly for it. If we change its x coordinate to 0 and its y coordinate to 0, we can find that it is located in the upper left corner of the whole stage. Why is it located in the upper left corner? This is because for the whole page, its origin is located in the upper left corner, so the relative position between such a text and its negative object, that is, such a point in the upper left corner, is a position controlled by such an xy coordinate. Similarly, if we change the coordinate of x to 100, we can find that it is a distance of 100 pixels away from such an origin. Through the ruler above, we can clearly find that it is a distance of 100. Similarly, if we change its y coordinate to 100, we can find that such a point is located at a position of its negative object, that is, a distance from 100 pixels to 100 pixels, but we should not forget when remembering such a knowledge point. Another key word is its origin. What is the origin? We can select such a text. We can pull it down in its property bar and find that it has an x origin and y origin. The current x origin and y origin are 0 and 0, 0 and 0, which means that it is located in the upper left corner of such a widget, namely, 0 and 0. If we change one of its x element points to 50%, we can find that one of its x element points is located at such a position. Because the y origin is 0, it is said that one of its origin is located at the position pointed by my mouse. Then the distance from such a position to the top is 100 pixels, and the distance from the left is also 100 pixels. Similarly, if we change a y origin to a 50 origin, we can find that the origin of such a widget is currently located in the positive center of such a widget, and the positive center is based on a negative object of it, that is, the position of the entire page is 100 and 100. In order to deepen everyone's understanding of the concept of negative object, I will add another object group on this page. In fact, such an object group is an absolute positioning environment in our absolute positioning environment. Similarly, we will give such an object group a little background color and give it a blue color. Let's put it here. The width of an object group is changed to 100, and then we add a text widget in such an object group. We can see that I then draw a text widget in such an object group and set a background color for such a text widget. We can see that currently such a text widget has an xy coordinate of 44 or 48. What does that mean? It is located in such a text widget. Its origin is 0 and 0, and the default is the upper left corner. However, for an object group like ours, its origin is 0 and 0 by default, and it is also in the upper left corner. So we can generally understand that at present, such a text widget, such an origin distance, such an origin position, is 44 of 48. Similarly, if I change such a text, its x to 100, we can find out, then prove that at present, such an origin distance, such an origin position is 100. Similarly, if I change y, if the axis is also changed to 100, you can find such an origin. Such an origin is just a width and height position of an object group like us. Similarly, I will add another text in this object organization. We will also add a background color to such a text. We will change the x of such an object group to 100, we modify the y-axis to a 50. we can find that these two texts are based on a position of such an object group. Therefore, we can vividly understand that in absolute positioning, I can only modify one of its xy coordinates to determine its position with the subcontainer. Okay, after the first point, let's scale the first principle. Let's learn the second principle. The second principle is to define the size of the pixel by the fixed width and height unit, and change its position by dragging the mouse. In this way, we can define the size of the second point, and then the first point is to define the size by the fixed width and height. We can select any widget in our absolute positioning environment, and we can find its width and height unit. It is pixel, and if I modify a size of such a text widget, I can drag it to our 9 dots. You can see that if I do one drag at will, it will change one size by one change. And if I want to change one of its positions, I can also make a simple drag, and one of its xy coordinates will change. So the second point is very easy to understand. Then let's look at the third point. The absolute positioning of widget is completely separated from the flow layout. Suddenly, we give such a sentence, completely separated from the flow layout. At first glance, it seems very abstract, but it is not particularly difficult to understand. The so-called streaming layout refers to our relative positioning environment, and the content in the relative positioning environment. We will share it with you in the next class. We can find that there has been some overlap between these two text widget, but even if there is overlap, there is no extrusion between the two text components, right? You see, I put this text here and this text here. They don't fight, do they? They just have an overlapping relationship. Even if there is some overlap, collision, and extrusion between the widget and the widget, it will not affect the layout of the other party. So we call it out of flow layout, and the absolutely positioned widget is completely out of flow layout. We also often use this feature to do some very cool series effect. We will share this with you when we build atoms in the UI in Chapter 3. Then finally, the widget in the absolute positioning environment is blue, which is quite easy to understand. You can see that at present, some of my widget in the object group are blue. Since I am building an absolute positioning environment, you can see that all my widget under frontend are cold. Even if I am under the frontend, I will add it again. Add a banner, you can find that the widget in it is also blue, so it can let us simply distinguish the current environment I live in. If you want to add a widget, and it is blue in itself, it means that it is in an absolute positioning environment. Here you can have a deep insight. For example, here I will build a relative positioning banner. When I select such a relative positioning environment, we can find that the widget in this environment turns into a white one. The white widget is that it meets one of our relative positioning rules. Then it does not break away from a flow layout. We will share this with you in the later courses. Such 4 rules will run through the learning of this lesson. So I will put it here and check it with all of us at any time, so that we can deepen one understanding. Next, we will learn some ways to add widget and widget layout in our absolute positioning environment. First, we add the method of widget, which includes the following steps. First, select the absolute positioning container with the added widget, and then select the widget we want to add in the widget column. The third point is to draw the size of a component to be added in the stage, as well as its position. We also make such a rule. Let's make it clear. First of all, select the absolute positioning container of the widget to be added in the number of objects. Our page is a container, and the banner is also a container. Such an object group is also a container. So we need to select where we want to add such a widget. For example, now I select the page first, and I want to add a text widget under the page. Add it here, and I will give it a color. We can find out what is the meaning of such a text widget at present. Its x is 116, and its y-axis is 396. At present, it is the origin in the upper left corner. Because we have not set any origin for it at present, it is said that its default origin is located in the upper left corner. Then the point distance in the upper left corner and the point distance of a page are 116 pixels in the horizontal axis direction, x-axis direction, and 396 in the y-axis direction. If we combine such a text with this, the yellow text almost overlaps. When we select such a yellow text, we will find that its XY is very different. Why? This is because the current text is based on our object group, that is, our blue container, which has some pixels from our page. Therefore, an element in it is only based on its own layout, so we still need to understand it better, that is the relative position of the origin, and the negative object is defined by the fixed XY coordinate, so the method of adding widget is very simple. You can draw such a widget wherever you want to add it. Okay, now our objects are a little messy. Let's delete these irrelevant elements first. Okay, let's leave a few texts. In our absolute positioning environment, there are usually the following 4 methods for us to align. The first point is that we also use one of our setting property most, the second point is our keyboard control, the third point is to use our auxiliary line, and then use a series of alignment tools of our menu bar. We first say at 1.1, we first destroy this, we set this in the lower left corner, and then we have a taste try. First of all, he said that the first point is to make an alignment by setting the property method, which is very easy to understand. For example, if I want to make the horizontal axis of these 3 things completely aligned, then what do I want to do when it is based on the fact that one of its origins is the upper left corner? I'll just set him the same x coordinate, right? So let's see first. If I want to align such a purple text, its x coordinate is 163, then I also set a coordinate of 163 for it. We can find that there is no alignment. Why? This is because we have set an origin for our current text, and we restore its origin. In this way, we can find that its x is aligned. Similarly, we select the following text, which is 163. Can we find that the 3 texts are completely aligned with our horizontal axis? Of course, there are many simple methods here, that is, if we want to set its property on multiple elements, we can choose more. The second is our keyboard control, the so-called keyboard control. Let's take an example. For example, for such a purple text, I let its lower part overlap with our yellow text. I'll increase the yellow text a little first. I want to make a comparison between its lower part and the yellow text below overlap. What should I do? We can first select such a purple text, and then click the key with the down arrow on the keyboard. You can notice that one of its outer axes will change. You see, I can click a little, or even press it for a long time, but I will make a crazy change. Then you can see whether it is almost overlapped, so this is how we use the keyboard. The top, bottom, left and right of the keyboard correspond. When I click the up button, its y-axis will decrease, when I click the down button, its y-axis will increase, when I click the top left button, its h-axis will decrease, and when I click the right button, its x-axis will increase. This is also a skill we often use when we lay out a small part, and then next, we use auxiliary lines to align. For example, if I want them all to be on such a line, we can pull such a horizontal line first, and then we can find a hint of coordinates on its y-axis. For example, if I want to make their y-axis at a point such as 230 pixels, I set my auxiliary line at a distance of 230, and then I select such a text net to drag, or use only the keyboard to control, so that it is aligned with such a line. Similarly, if you want to align here, we also carry out an auxiliary control through our keyboard, so that it can be aligned. If you don't need this auxiliary line, you can drag it back, but you can directly click one here to hide all auxiliary lines. Next, another common tool is that we use the menu bar tool to align. What is the menu bar alignment tool? On this side there is a series of attributes, such as left, center, right, bottom, and top. We can take a look first. For example, I make a multiple selection here, and then I select a left alignment of it. We can find that it is aligned based on the leftmost element. Similarly, if we put such an element on the left in such a position, I will select more, and then select the left alignment on our side. It will align with the leftmost element on the stage. Similarly, the left alignment and right alignment are almost the same. I drag this element to the far right to select a right alignment, and it will align with our rightmost element. Align such an element. Similarly, if it is the top alignment and the bottom alignment, it will select the uppermost or lowermost element we currently select for alignment, so we won't repeat it. Next, there is an alignment method of left-right centering. It will calculate a position of all our elements, and then find such a line in its horizontal. Let's help us make an alignment. For example, drag it to the left, and then I will make a multi-choice, and then I will select one of its left-right centering, and I can find that it will first find such an element and a position in the element, and then help us make an alignment. The same principle is to center up and down. It will find such a position in all the current elements. Click it, and it will align us up and down. You see, when we choose the left and right alignment, and then up and down alignment, you see, we have done a kaleidoscope-like effect. This is an alignment method on the left. Secondly, there are a series of alignment methods on the right. For example, we use a lot of vertical equal spacing and our horizontal equal spacing. For example, the three texts tell that it is a unified size. Let's set it casually. For example, its unified size is a size of 200 pixels multiplied by 80 pixels, and then we carry out a random drag on one of its levels, and then I hope that the three elements are vertically equidistant, so I can choose a vertical equidistant function here, and you can find that it helps us to automatically carry out an equidistant, and the distance between the two elements is exactly the same as the distance between the two elements. Similarly, I can also cooperate with a left-right centered effect here to make it have a centered effect, so that we can quickly align. Then, similarly, if the left and right distance on my side is also random, then I can make a multiple selection, and then select a horizontal equal spacing on this side, so that the horizontal spacing of the three elements is also equal. This is the last point, which is to use the alignment tool of our menu bar for alignment. Okay, I'll set the width and height for them. The first is 80 of 80, then the second is 150 of 150, and then the third is 200 of 200. Then I set the same XY coordinate for them, 50 for X coordinate, and 200 for Y coordinate. We found that we can only see text 3. Where is text 2? Text 2 is here, but we can't see it. Why can't we see him? I believe smart students have found it. Why can't they see it? Is it because it is blocked? This involves a new knowledge point, that is, our hierarchical relationship. Let's first take a look at the definition of hierarchical relationship. Hierarchical relationship mainly includes the following two knowledge points. First, the larger the stacking order at the same level, the higher it is. Secondly, if we say that under different hierarchical relationships, the hierarchical relationship of negative objects shall prevail, how can we understand this? Let's give it down and put it below for a simple understanding. The first point is that under the same hierarchical relationship, the larger the stacking order, the higher it is. For example, if you look at the whole text 3, it is our largest text, which is located at the top of our object book, so for now, it blocks the following two texts. Similarly, what if I want our small text to be displayed on our text? I can directly drag it to the top of our object pairs, so it will also be above our text 3 in the actual display. However, if we need to drag it when we all modify the queue order, it must be too troublesome. In more cases, we still use the stacking order method for setting. For example, for such a text 2, I want it to be displayed at the top, so I set a stacking order of 3 for it. For such a text 3, I want it to be at the bottom, so I change the alignment order of 1, and then for such a text 1, it should be between the two, so I give it alignment order of 2, and then call it come out. He is blocked at present, so look, who is at the bottom of our level? It is such a text 3. Its opposite evidence is 1, so it is below, and then there is our text 1. You see, part of it is blocked, so for such a text so far, its comparative data is the highest, which is 3. So the first point is that at the same level, the larger the stacking order, the higher it will be. Secondly, for different hierarchical relationships, the stacking times of negative objects shall prevail. How to understand this? Here we simply build an object group, and then we give the object group a color, give it a blue, and then give the object group. We first set a queue order for it, and its queue order is unique, and then throw all three texts into it. Then, similarly, we pull another object group, and change its background color to 1 green, we change a queue order of such a new object group to 0, and then we select object group 2, we add a text widget for it, and set the background color for it. It can be found that, the text I added now is located under such an object and a group of all texts. Why? This is because at present, for a green object group, its queue data is 0, which is smaller than the opposite order of our blue object group. Some students may say that you have not set a stacking order for this text. Let's set a stacking order of 100 for it. Let's have a look. We can notice that, even if I set the opposite data of a text group to 100, but I didn't jump over the text in object group 1, why? This is the second point, that is, under different levels of relations, a stacking order of negative objects shall prevail. You can see that since the newly added object group 2, its queue order is 0, while the previously set object group 1, its queue order is 1, so the object group 1 is always larger than its object group 2, so how can the widget in the object group 2 work hard? Even if the component in the object group 2 works hard, it has been set to the order of 100 queues, and it still has no way to be higher than the widget in object group 1. Therefore, when making actual settings, we must correctly set a queue order of its negative objects. Then we just used such an object group. Let's deepen our understanding, that is, by fixing the xy coordinate, we define a relative position between the origin and the negative object. Now I drag such an object group 1, we can find that the xy coordinate on the left side is constantly changing, and then a text in it is following. Why? Because for a negative object, you can see that it is now 18. I drag such an object group again. You can see that such an object in it is still 18, so it always follows a position of one of its negative objects. Therefore, if a position of an object group is modified as a whole, all its sub-objects will move together.